Okay, so here we are with lesson 3C. Today, students will be able to simplify expressions by combining like terms involving rational numbers. Remember, combining like terms means we're going to combine the coefficients of the variable terms and the constants. Underline coefficients of variable terms and then underline constants. Remember, constants are just numbers with nothing else on them. Coefficients of variable terms means numbers in front of letters. We're going to combine the numbers that are in front of letters and the numbers that are separate. Okay, so that's what it means. The coefficients of variable terms are the numbers in front of the letters because it's a number multiplied by that variable. All right, and then students will be able to identify the different parts of expressions. This is important for solving multi-step equations, which are coming in the future. So today we're going to continue with combining like terms. It's the same thing really that we've been doing. It's just that this time some of them will be decimals and some of them will be fractions. So remember, you're either going to want to change the fraction to a decimal by dividing or change a decimal to a fraction with place value. Place value. All right, so let's look at our first example. Number 1, I see some variable terms and I see some constants. So I'm going to underline my variable terms. So these two are variable terms because they have the letter F as a variable. So I know I can combine those. I'm going to write something there. And then these are my constants off to the side because neither of these has a variable attached. So I'm going to combine those together separately. All right, and then I'll write their answer there. So let's focus on the variable terms first. I see the coefficient 0.4, so I'm going to write that over here, 0.4, and I see the coefficient negative 1/3. Negative 1/3. So I'm going to write it like this, separate from their variable, but I do know that these are the F's, right? So I'm going to separate, kind of like we did in that last lesson. Let's separate the variable terms from the constants. So these were the coefficients on the F's, and I need to combine those. Remember, a minus means add the opposite. So I know that, but this is a decimal and that's a fraction. I could change the fraction to a decimal by dividing, but I know that thirds repeat, and so that's not going to be an accurate decimal. So instead of changing this one to a decimal, I've got to change this one to a fraction. But that's pretty easy. This is said 0.40 and 4/10. And so since I said 4/10, I write 4/10 plus negative 1/3. Now before I make common denominators, I see that I can reduce this by 2. And so I'm going to go ahead and reduce that first so that I have smaller numbers to work with. That makes this 2/5 plus negative 1/3. And now I see that I can make some common denominators. My best common denominator here is going to be a 15. I know I can get to that from both of those. So to get to 15 from here, I need to multiply by 3. To do that to the top gives us 6/15. On this side, I need to multiply by 5, and so that gives me negative 5/15. 6/15 plus negative 5/15 is going to give me 1/15 left over. So that was my variable term. That was my coefficient. And so I'm going to write that over here. My coefficient is going to be 1/15. 1/15 for the variable F. Those were the F's. Now on to my constants, 2/3 minus 0.2. And again, thirds, I already know are going to repeat. Let's write constants over here so we know what this is. These are the constants. Over here, I'm going to write the constants. So that's 2/3 minus 0.2. Remember, all minus is plus a negative. And again, I know thirds repeat, so that's not going to be a very accurate decimal, so I'll work with changing the decimal to a fraction. So this is going to say 2/3 plus, and 2/10 is 2/10. Once again, I see that I can reduce, and oh, don't forget the negative there. Once again, I see I can reduce by 2, so I'm going to go ahead and do that before I make the common denominators. So this will be 2/3 plus negative 1/5. And now I make that common denominator. It happens to be the same as before. So I'll make these both 15ths. This would become 10/15. This would become negative 3/15. And 10/15 plus negative 3/15 is going to be left with 7/15 because I had more positives than negatives. All right, so that's a positive 7/15 for my constant. So I'm going to write over here positive 7/15. And I can't combine anything else because this has a variable and that one doesn't. And so this would be my simplified answer. All right, let's try that again down here. I'm going to look first at my fractions. I see that this is sevenths. That's not a very pretty one to write as a decimal. This one's halves. That one's a little bit better. But let's go ahead and stick with making these decimals to fractions. That might actually be the better route because some decimals just aren't going to be very accurate. All right, let's look first for our variable terms. I see that this one has an M, that one doesn't. This one has an M, that one doesn't. So I'm going to work first with my variable terms. So on my side work, I'm going to write my M over here as I separate my two sides of side work, the ones with the M's, the ones without the M's. The coefficients on the M's are negative 0.7, and that's a positive 5 halves, plus 5 halves. So that's really the work we're doing. I'm going to change this decimal to a fraction, negative 7/10 plus 5 halves. And I'm going to make my common denominator of 20 because that's going to be my easiest route here. For this one, I had to multiply by 2 to get there, so this would be negative 14/20. For this one, I had to multiply by 10, and so this would be 50/20. Do I have more positive or more negative? Well, I have more positive, and I need to subtract because these are different signs. So 50 take away 14, let's do that. Let's think, oh, that's going to be 36. Yeah, 36/20. Did I have more positive or more negative? Well, I had more positive, so that's going to stay positive. And let's rewrite that as a mixed number. So let's see, I can take one group of 20 out of there, and I would have 16 left over. And I can reduce that by 2. And we get 1 and 8/10. Oh, I can reduce it more than that. Let's reduce by 2 again. So that means I get 1 and 4/5. Okay, I think that's as low as we can go with reducing. And so that's my coefficient on the M. 1 and 4/5 has the M. Now we go on to the constants. 5/7 minus 0.25. 5/7 minus 0.25. So I'm going to write that over here. Here's my constants. Constants. 5/7 minus 0.25. Remember, minus means add the opposite. And I want to rewrite that one as a fraction. And so I'm going to write that as 5/7 plus, well, this is 0 and 25 hundredths. So negative 25 hundredths. But I can definitely reduce this before getting to that adding stuff. So I'm going to reduce this by 25s. I happen to know my quarters, and I know that this is divisible by 25. Don't mind that bell. You're going to hear a couple of those today. All right, so this is going to become 5/7 plus negative 1/4. That's a much easier number to work with. Let's look at this. So in fourths and sevenths, I think the only common denominator here is going to be 28ths. So let's go ahead and change both of these to 28ths. To get there from the 7, I multiply by 4. So this will become 20/28ths. To get there from the 4, I multiply by 7. So this is going to become negative 7/28ths. 20/28ths plus negative 7/28ths is going to give me 13/28ths left over. Add more positives, so it'll stay positive. All right, so that's my constant. I can't do anything else with that. I can't reduce, and so over here, I will write plus 13/28ths. And that's going to be my answer because these were the variable terms. That's the constant. This one has a letter. That one doesn't, so I can't combine any more than that. That's my answer. All right, let's move on to the back. Remember, you could always pause this and watch this stuff again if you need to. But let's go ahead and look at one more example. What do we have? 2 more. Oh, that last one's pretty easy. Let's look at this one. I see an X, I see an X, no X, no X, no X. All right, so those two are going to be combined first. These have X's. All right, so my X's, the coefficients on those X's are 1/5 minus 0.22. I'm taking the sign that's in front of the number, so this is a positive 1/5. That's a negative 0.22. Positive 1/5, negative 0.22. This time I'm going to go ahead and change this fraction to a decimal because I know that one stops pretty quickly. Remember to do that, we take the top dog in the doghouse, 0.0. When we divide, how many 5s can I take out of 10? 2. That gives me 10 exactly. So this would be 0.2 as a decimal. Do you see why I wanted to change that? Because that's a lot easier to work with. Remember, it's minus, so add the opposite. Should have done that up here. There we go. Add the opposite. So do I have more positive or more negative? Well, if this said 0.20 and this said 0.22, I have more negatives. And so let's go ahead and subtract that. 0.22 minus 0.20 means I have 0.02 left over. And so I had negatives, more negatives, 0.02. And so those are my x's, and so that's the coefficient on my x. I would have negative 0.02 times x, like that. And now for all these constants, I have 1.1, negative 1/2, minus a negative, add the opposite. I'm going to go ahead and do that now, and then I'll circle that one. So here's all my constants written to the side. So I have 1.1 minus 1/2 plus 0.2. Okay, and I have one minus that I copied down, so add the opposite. And I'm looking at this 1/2, and I really just want to write that one as a decimal. These two are decimals. This one I know is one that will stop pretty quickly. So let's go ahead and divide that. 1 divided by 2, 0.0. How many 2's can I take out of 10? Well, that's 5. And I have nothing left. And so this would be 0.5. So I'm going to rewrite this. 1.1 plus negative 0.5 plus 0.2. And I'm just going to work this 2 at a time. 1.1 minus 0.5. If you need to work that out, I'm going to write that here. Minus 0.5, borrow. And we'd have 6 left over, and the 0. There we go. So we would have 0.6 plus 0.2, and I know that would be 0.8. All right, so there's my constant. My constant is 0.8. So over here, that was a positive 0.8, and I know that that's my answer because the first term has an x, and the second one doesn't. So I have to keep it at that. All right, let's go ahead and look at this very last one. Which of the expressions below are equivalent to this? All right, so I have to see which ones have variable terms that will add up to negative 3/8, which ones have constants that will add up to 2.75, positive. So let's check this one. If I add the opposite here, I know my constants would work out. Those work out to 2.75 because 1 and 1 is 2. 3 would be added to the 4, that's 7. So constants work out. Let's check the fractions. Negative 1/4 plus negative 1/2. Let's work that one out. Negative 1/4 plus negative 1/2. I'd have to change this one to fourths. Negative 1/4 plus negative 2/4 equals negative 3/4, which is not negative 3/8. Nope, that one does not work. What about this one? Negative 0.375x plus positive 2 3/4. Looks like they're trying to switch up the formatting there. So let's see if that would work out to equal this. So 0.375. I don't want to write that as a fraction and work on reducing. I'll take this fraction and write it as a decimal instead. So let's see what happens when we divide 3 by 8. 0.0, that can go in 3 times, gives me 24, 6 left over. Bring down a 0. 8 goes into 67 times, gives me 56, 4 left over. Bring down another 0, and 8 goes into 47, or 5 times. That gives me exactly 40, nothing left. So that decimal does match this fraction. So far, so good. Let's check this fraction to match that decimal. Let's check 3/4. What happens when I divide 3 by 4? 0.0. 4 goes into 37 times, gives me 28. 2 left over. Bring down the 0. 4 goes into 25 times. Exactly. So that would be 0.75. So that would be 0.75. So this one works. Ooh, look at this one. All right, we've got a minute to work this one out. All right, let's look at these. Negative 1/8 and another negative 1/8. Ooh, and another negative 1/8. That's negative 3/8 x. What about 5 minus 2.5 or 2.25? 5.00 minus 2.25. Let's borrow and borrow. There we go. That'd be 5, 7, and 2. Ooh, those work out to a positive 2.75. Looks like that's a match. All right, if you need to see that again, remember you are welcome to pause the video at any time and go back. Otherwise, yay math. Try your exit ticket.